The rain has no name here. It simply falls, relentless and warm, as if the island itself is sweating. He's been lying in this trench for 4 hours. Staff Sergeant William Dawes of the 1st Marine Division, 23 years old. Mud in his ears, mud under his fingernails, mud between his teeth from when he bit down during the artillery barrage 2 clicks north. His M1 Garand is dry, he made sure of that, wrapping the receiver in canvas before the rain came. But the bolt is starting to feel stiff. The humid air does things to metal, to men, to certainty. The jungle presses in from all sides. Every sound is a decision, a broken branch, animal or enemy. Silence for 3 seconds. Then the silence itself becomes something to fear. His ammunition is down to 11 rounds. His radio has been dead since 0300. His partner, Corporal Esteban Ruiz, is 40 meters behind him, covering the trail, or was. He hasn't heard Ruiz move in 20 minutes. Something moves in the undergrowth, 12 feet, maybe 10. The Garand comes up instinctively, but Dawes doesn't fire. A shot at this range at this hour, in this direction, would light him up like a flare. Would announce exactly where he is. Would bring more than one set of boots toward him in the dark. The rifle is not the answer, not right now. His right hand leaves the Garand and drops to his hip. His fingers find the leather sheath by muscle memory. He has practiced this motion 10,000 times, in training, in boredom, in the cold steel dark of a transport ship. The snap opens without noise. He draws it slowly, 7 inches of steel. The weight is immediate. Solid, dense. Not the nervous lightness of uncertainty. This is the weight of something designed to do exactly what is needed, exactly when it is needed, by someone who will not get a second chance. The grip is leather, stacked rings of it, pressed and shaped until it sits in the hand, like an extension of the bones themselves. The rain has soaked it, but that somehow makes it better. The texture holds. He does not think about the blade. He does not admire it. He is not afraid of it. He is simply grateful it exists. The movement in the undergrowth stops. 3 seconds. 4, 5. A rat. A large one, scrambling over a root and disappearing into the black. Dawes exhales. Slow, controlled. The blade goes back in the sheath. But he does not snap it closed. Not yet. Not yet. From the jungle to the archive, how a blade became legend. That blade was not a fantasy. It was not designed by committee or born from a marketing brief. It came from a specific need in a specific moment in American military history, forged from the lessons of men who had already bled on the wrong side of poor equipment. The knife that Sergeant Dawes held in that Guadalcanal trench, or one nearly identical to it, was the Ka Bar fighting utility knife, officially designated by the United States Marine Corps as the 1219C2 fighting utility knife. But no one called it that. No one has ever called it that in a trench. In 1942, the United States Marine Corps issued a formal requirement. They needed a fighting and utility knife that could do what the existing options could not. The standard issue Marine Raider stiletto, a slender, elegant, purely offensive weapon, was excellent for one thing and one thing alone: kill. But a Marine in the Pacific needed to cut rope, build shelter, open rations, dig into earth, pry metal, signal with steel, and yes, fight. The stiletto could not do those things. It was a specialist in a world that demanded generalists. The Ka-Bar Cutlery Company, based in Olean, New York, answered the call. The company's name, Ka-Bar, is itself a piece of American folklore. According to the company's own records, the name came from a barely legible letter from a fur trapper who wrote to the company praising the knife he had used to kill a wounded bear after his gun misfired. The handwriting was smeared, the words partially illegible. What he'd written, kill a bar, became, phonetically and permanently, Ka-Bar. The USMC officially adopted the Ka-Bar fighting utility knife on November 23, 1942. The United States Navy followed shortly after. Union Cutlery, the parent company behind the Ka-Bar brand, and 6 other manufacturers were contracted to produce the knife at scale. Each manufacturer stamped their own mark on the blade ricasso, which is why collectors today distinguish between Ka-Bar marked blades and those marked by Camillus, Robeson, Case, Kinfolks, Pal, and Colonial. By the end of the war, over 1 million of these knives had been issued. Marines carried them ashore at Tarawa, Iwo Jima, and Okinawa. Sailors kept them on their belts in the North Atlantic. They pried open ammunition crates, cut parachute lines, notched tent stakes, and occasionally, in the worst moments that war manufactures, they were used exactly as their name implied. Major General Commandant Alexander Vandegrift himself praised the knife publicly, calling it an outstanding piece of military equipment. This was not rhetoric. This was a man whose Marines had died in jungles, on beaches, and in the Pacific rain, and he was saying, this thing helped them survive. After World War II, the K-Bar went to Korea. It went to Vietnam. It served in Desert Storm, in Afghanistan, in Iraq. Every generation of American military operators has encountered this knife, often in the same form, with the same geometry, made of the same steel, and reached the same conclusion. It works. It has always worked. That is not nothing. In military history, that is almost everything. The engineering of survival. What the steel actually does. To understand why the Ka-Bar USMC has endured for more than 80 years without fundamental redesign, you have to stop thinking about knives and start thinking about physics. The blade is constructed from 1095 high-carbon steel, alloyed with chromium and vanadium, a combination often identified as 1095 Cro-Van, the specific variant used by the original USMC specification Ka-Bar. This steel is not exotic, it is not cutting-edge metallurgy in the modern sense. What it is, however, is profoundly understood. 1095 high-carbon steel sits at approximately 95% carbon content by weight. That percentage matters. Below 0.60% carbon, steel is ductile, tough, but it will not take a fine edge and will not hold one under sustained use. Above 1.10%, steel becomes harder, capable of a finer, more acute edge, but also increasingly brittle, prone to snapping rather than bending under lateral stress. 1095 occupies the working zone, hard enough to take a working edge, resilient enough to survive the kind of abuse that operators in the field actually subject their blades to. The chromium and vanadium additions in the Cro-Van variant serve precise purposes. Chromium at low concentrations, far below the 10.5% threshold needed for stainless classification, improves hardenability, meaning the steel responds more predictably and completely to the heat treatment process. Vanadium contributes to grain refinement. Finer grain structure at the molecular level means a more uniform edge, less prone to microchipping under hard cuts. These are not marketing terms. These are crystallographic realities that directly determine how the knife behaves when Sergeant Dawes is cutting through bamboo, rope, or a combination of both in a dark jungle at 0300. The heat treatment applied to USMC spec K-Bar blades targets a Rockwell hardness of 56 to 58 HRC. This is the engineering decision that defines the blade's character more than any other single factor. At 56 to 58 HRC, the steel is hard enough to hold an edge through sustained working cuts, the kind of repetitive utility use that military knives endure. But it remains soft enough to resharpen in the field using rudimentary tools. A Marine with a ceramic stone, or even a flat rock in an emergency, can restore a working edge to this steel. At 62 HRC, the steel would be harder, the edge sharper and longer lasting under light use, but field sharpening becomes difficult to impossible, and lateral shock resistance drops sharply. The Ka-Bar's heat treatment is, in the most literal sense, a survival-focused engineering decision. The blade geometry. Why the clip point? The Ka-Bar USMC blade is 7 inches long, with a profile known as a clip point, or more accurately, a modified clip point with a false edge running along the spine toward the tip. Understanding this geometry explains the knife's versatility in the way that understanding a lever explains physics. The clip point's defining characteristic is the concave or straight cut on the upper spine of the blade toward the tip, which reduces the mass at the point, and lowers the tip's center of gravity relative to the rest of the blade. The practical result is a tip geometry that allows for precise, directed thrusts, necessary in any fighting application, while the fuller lower belly of the blade retains substantial material for drawing cuts, slicing, and chopping. It is a dual-purpose geometry. The tip serves offense and precision, the belly serves utility. The false edge on the spine, not a full secondary edge, but a beveled reduction, serves a supplementary function in thrusting. It reduces the material that must be displaced as the point enters a target, requiring less force for penetration. In field applications outside of combat, it also allows for some two-direction cutting leverage when working in confined spaces. Blade thickness at the spine is approximately 6.5 millimeters, a quarter inch of steel, running down the back of the blade. This is substantial. It contributes directly to the blade's lateral rigidity, meaning when the knife is used as a pry, a lever, or as a digging tool, the spine does not flex catastrophically. It bends slightly and returns. This is not incidental design. It is deliberate structural engineering for the reality of field use. The full tang, the skeleton of confidence. The Ka-Bar USMC is a full tang knife. This is the most important structural fact about the blade. The tang is the portion of the blade steel that extends into the handle. In a partial tang or rat-tail tang design, the steel narrows dramatically behind the ricasso and is held in place by a pin, adhesive, or compression fit within the handle material. These designs can be beautiful. They can be functional for light use. They are not acceptable for military field applications. In a full tang design, the steel of the blade continues at full width and thickness through the handle itself. The handle material, in the Ka-Bar's case, stacked leather washers compressed and bonded on the tang, is fastened around this continuous steel structure, not to a narrowed extension of it. The pommel, a steel oval cap, is peened onto the end of the tang, compressing the leather stack and creating a handle assembly that is, functionally, as strong as the steel itself. What this means in the field: the Ka-Bar USMC can be used as a batoning tool, driving the spine with another object to split wood. It can be used to pry. It can be driven into the earth and used as a piton in an emergency climb. It can take forces that would separate a partial tang handle from its blade within minutes. The full tang is the reason none of those forces compromise the tool. The steel is one continuous piece, from tip to pommel, and that continuity is structural integrity in its most elemental form. The leather handle, not nostalgia, function. The stacked leather washer handle of the original Ka-Bar USMC design is often discussed as a historical artifact, a nod to tradition in an era of G10, micarta, and rubber-molded polymers. That reading misses the engineering. Stacked leather is a composite material. Each washer, pressed from dense, oil-treated cowhide, contributes fiber orientation in a slightly different plane than the washers above and below it. The result, under compression, is a handle material that combines resistance to splitting, absorption of shock, and textured grip, even when wet. The oils in the leather interact with the moisture from a wet hand or rain, increasing friction rather than decreasing it. This is the opposite of most smooth synthetic materials, which become slicker under moisture. The leather does develop a patina over time. It does absorb sweat, blood, oil. In the field, these are not contaminants. They are the material adapting to its user, conforming to the specific geometry of a specific hand after months of carry and use. Marines in the Pacific describe their Ka-Bar handles as feeling broken in after a few weeks, the way a quality boot feels after the leather has shaped itself to a foot. That adaptation is not weakness, it is fit. The Ka-Bar USMC weighs approximately 11.4 ounces in the leather sheath. The blade itself, without sheath, runs between 7 and 7.2 ounces depending on manufacturing batch. The balance point falls slightly forward of the guard, toward the blade, not the handle. A blade forward balance is a specific engineering choice for a knife intended for chopping and thrusting as primary functions. The weight of the steel toward the tip adds momentum to a downward chopping stroke, reducing the muscular effort required to cut through material. It also means that in a thrusting motion, the blade's mass is moving in the same direction as the thrust, contributing to penetration. Handle forward balance, conversely, benefits fine control and precise cutting, the domain of kitchen knives, scalpels, and carving tools. The Ka-Bar's balance point is not an accident, it is a declaration of purpose. To understand the Ka-Bar, you must first understand what it replaced and why that replacement was urgent. When the United States entered World War II, following Pearl Harbor on December 7, 1941, the Marine Corps was not well equipped with a standard issue fighting knife. What existed were several legacy designs with significant limitations. The M1917 and M1918 trench knives from World War I were heavy, cumbersome, and poorly balanced. The USMC Mark I utility knife was adequate for basic tasks, but lacked the blade geometry and structural integrity for sustained combat or heavy field use. The OSS-influenced stilettos being issued to raider battalions were purpose-built for assassination, extremely narrow, double-edged, and functionally useless for anything that wasn't killing. The Marines going ashore in 1942 needed something that could open a ration can, cut parachute cord, split bamboo for a lean-to-frame, serve as an emergency pry bar, and if it came to that, be used in close-quarters combat, where a rifle's length became a liability rather than an advantage. No single existing design met all of those requirements. The USMC's formal request to the industry in 1942 specified the need for a knife with a blade of approximately 7 inches, a sturdy handle, a blade geometry suitable for both fighting and utility work, and construction rugged enough to withstand the conditions being reported from the Pacific Theater, extreme humidity, salt exposure, mud, and the mechanical abuse of daily field use. Union Cutlery Company of Olean, New York, producers of the Ka-Bar brand since the late 19th century, had been manufacturing quality hunting and utility knives for American consumers for decades. Their engineering and manufacturing infrastructure were oriented toward durability and function over aesthetics. When the USMC requirement arrived, Union Cutlery's designers produced a pattern that drew from existing traditions in American hunting knife design, particularly the clip-point Bowie tradition, which American blade makers had refined over more than a century, and adapted it explicitly for military utility. The design team at Union Cutlery did not conduct ethnographic research or run focus groups. They looked at what Marines needed, looked at the materials they had available, looked at the manufacturing processes already running on their production lines, and produced a pattern that could be manufactured at scale without compromising the structural and functional requirements of the spec. The first production runs came off the line in late 1942, and by early 1943, Marines in the Pacific were carrying them in combat. The designers at Union Cutlery did not become famous. Their names are not in military history books. What they made is in museums, in hands, in sheaths on the belts of working operators 80 years later. That anonymity is, in itself, a testament to the nature of the work. They solved a problem, completely, and then stepped back. The tool spoke for itself. It has been speaking ever since. We live in an era of extraordinary technology, thermal optics, satellite communication, composite body armor, GPS navigation accurate to 3 feet anywhere on Earth. The individual operator of the 21st century has access to systems that would have seemed like science fiction to the Marine, standing on the beach at Iwo Jima. And yet, the knife on his hip is nearly identical to the one on Sergeant Dawes's hip in 1942. This is not nostalgia. This is not institutional inertia or failure of imagination. This is a recognition of something fundamental about the category of tool a knife occupies, and what that category demands of the object within it. A knife does not require a battery. It does not require a signal. It does not require a software update, a calibration cycle, a charging period, or a functional network. It does not malfunction when submerged in salt water, dropped in mud, or exposed to extreme cold. It does not have a firmware that can be hacked, a circuit that can be fried by electromagnetic pulse, a display that washes out in direct sunlight. It requires only one thing: a hand. And the hand must make a decision. This independence from infrastructure is not a minor feature. In military and survival contexts, it is the core value proposition of any unpowered tool. The Ka-Bar's value is not that it is sharper than the alternatives, or lighter, or more ergonomic. Its value is that it will be there, functional, when everything else has failed. There is a psychological dimension to carrying a serious blade that is difficult to articulate without sounding mystical, but that serious operators acknowledge plainly when pressed. A knife on the hip is not primarily a weapon in daily use. In military field environments and in serious civilian preparedness contexts, the knife is used for food preparation, cordage management, wood processing, first aid applications, cutting bandages, cutting away clothing around wounds, and dozens of small mechanical tasks that accumulate over the course of any extended operation. The fighting application of a military knife is statistically rare relative to its utility applications. But the presence of the blade, its weight, its solidity, its permanence at the hip, communicates something to the person carrying it about their own state of preparation. It is a physical statement of readiness, not aggression. Readiness. The distinction is critical. An operator who knows with certainty that a reliable cutting tool is immediately accessible changes how they move through uncertain environments. Their decision tree is different. When a rope needs cutting, the calculation is not, do I have the tool for this? It is simply, where and how. That cognitive reduction, the elimination of the uncertainty about tool availability, is one of the less discussed functions of reliable equipment. It reduces cognitive load. In high-stress environments, reduced cognitive load is a survival advantage. The Ka-Bar USMC, with its consistent geometry, its weight that a trained hand learns to internalize as a baseline, and its mechanical simplicity, contributes to this reduction. Marines who carry it long enough stop thinking about it as a separate piece of equipment. It becomes part of the load, the way a wedding ring becomes part of a hand. Its absence, by that point, would be more notable than its presence. There is also something in the material itself. High-carbon steel, properly finished, has a visual and tactile quality that is unlike modern polymer composites or stainless alloys. It reflects light with a particular depth. It develops a patina, and in humid environments, if not maintained, it will develop surface oxidation that communicates use, age, and continuity. A kabar that has been carried for years looks like it has been carried for years. It is not ashamed of this. It is, in a sense, marked by its service, which is exactly what a military tool should be. The following scenario is a composite drawn from field accounts and training scenarios used by military survival instructors. It is not attributed to a specific individual. It is attributed to a type of situation, the kind that happens when things go wrong in the way that field conditions permit them to go wrong, which is to say, several things at once and faster than the plan anticipated. It is 2200 hours. A two-man reconnaissance team has been inserted by helicopter 40 kilometers behind what the mission brief called a soft boundary. The boundary was soft in the same way that the weather briefing called the approaching front manageable. Neither assessment aged well. The rain arrived at 1730. By 1900, the team's primary radio was submerged when the lead operator went through a section of trail that the satellite imagery, taken 3 days earlier, in a different weather pattern, had shown as solid ground. It was not solid ground. He went into his chest. The radio in its waterproof case was knocked free and carried 30 meters downstream before they found it. The waterproofing had held, but the antenna connection had separated. And without the antenna, the radio was a dead box of circuitry. The backup radio was functional, but its battery had been compromised by the same fall that took the primary. They had approximately 40 minutes of transmission capability. Command used the first transmission to push a new extraction window, lure 400 hours, at a clearing 2 kilometers north of their current position. They acknowledged. The backup radio then died. 2 kilometers of jungle, a night in heavy rain, with a compass and a damaged map. They moved. At 2245, the lead operator, we'll call him Torres, encountered the first obstacle. A fallen tree, massive, blocking the natural drainage channel they'd been using as a navigation reference. The tree was too large to step over and too slippery to climb quickly in the rain. Going around would cost 20 minutes. Cutting through the secondary branches and undergrowth tangled around the trunk, was the option. His multi-tool saw blade had broken 2 days earlier on a previous task. His machete had been left behind to reduce pack weight. It wasn't on the original equipment list for this mission type. What he had on his hip was a 7-inch blade. He worked for 11 minutes, cutting branches at their base, not their tip, using the full blade, drawing through rather than chopping, conserving energy. The kabar moved through green wood with controlled effort, not fast, but consistent, steady. The edge did not fold, did not require redressing. He cut through 16 branches of varying thickness, the thickest approximately 3 inches in diameter. The last 4 required multiple passes and more force, the blade biting with each stroke, the full tang absorbing the lateral stress of wood that didn't want to give. They went through the tree at 22:56, 11 minutes. Their schedule still held, barely. At 01:15, Torres' partner, Delgado, cut his hand on a section of barbed wire that shouldn't have been there, at waist height, stretching between 2 trees in the darkness. The cut was on the palm, 4 centimeters, not deep enough to be an arterial emergency, but deep enough to bleed heavily and to compromise grip strength. He needed his hand bound. They carried a compact first aid kit. Inside it, a roll of medical gauze. The gauze was in a sealed package. The packaging was waterproof, the seal intact. The packaging was also, in the rain slick dark, impossible to open with wet fingers. Torres tried for 30 seconds. He estimated they had lost 15 more. He drew the kabar, 1 controlled cut. The package opened. The gauze was out in 45 seconds total. Delgado's hand wrapped and pressure applied in 3 more minutes. They reached the extraction clearing at 03:47, 13 minutes ahead of schedule. The helicopter arrived at 04:02. They were in the air by 04:10. Debrief. The multi-tool failure. The radio loss. The fallen tree. The wire. 4 separate moments where the mission could have degraded into something worse. In each of those moments, the knife was what worked. Not gloriously. Not dramatically. The way a structural beam works. Invisibly, supportively, holding things up that should not fall. The K-Bar USMC is manufactured today in nearly the same form as it was in 1942. Union Cutlery's K-Bar brand, now operating under the K-Bar Knives Company based in Olean, New York, continues to produce the USMC spec knife with 1095 Cro-Van steel, the stacked leather handle, the full tang, The clip point blade geometry. The specifications have been refined. The quality control is better than it was in wartime production. The fundamental design is unchanged. This raises an obvious question. In a world of CPM S35VN M390, Bowler K390, nice and Lumalo super steels with edge retention measured in objective testing parameters that 1095 cannot approach, why does this knife still matter? Why not a modern steel, a modern handle, a modern design? The answer is layered, and none of the layers are sentimental. In the bushcraft community, individuals who practice wilderness living skills, primitive construction, and extended outdoor survival, the Ka-Bar USMC has found a second life that would have surprised no one who understood its original design brief. A knife built for the jungle is, structurally, a knife built for the forest. The demands are similar. Wood processing, cordage work, food preparation, shelter construction, firecraft. The 1095 steel's edge characteristics are, in some ways, better suited to field sharpening than modern super steels. When a bushcrafter is 60 miles from the nearest store, their sharpening options are a pocket stone, a ceramic rod, or a flat rock from a stream. 1095 Cro-Van, at 56 to 58 HRC, responds to all three. An S35VM blade at 60 plus HRC may perform better under controlled conditions and hold an edge longer under light use, but when the edge is gone, getting it back in the field requires more time, more skill, and better abrasives. The Ka-Bar is maintained by the available, not the optimal. That is a field-relevant advantage. The blade length, 7 inches, sits at the working edge of what is useful for baitoning without tipping into the cumbersome. Knives under 5 inches struggle with larger wood-splitting tasks. Knives over 9 inches gain mass and wind resistance that slow utility work. 7 inches is the practical middle, long enough to process medium firewood, short enough to handle fine carving with control. There are tools that represent their era, and then there are tools that transcend it. The Ka-Bar USMC is not the sharpest knife made. It is not the lightest, the most corrosion-resistant, the most technologically advanced. In any objective benchmark that measures edge geometry in micrometers or steel performance in laboratory wear tests, it will lose to a dozen modern alternatives that cost twice as much and require maintenance that was never designed for a man lying in mud in the dark. What it is, precisely and completely, is the thing it was designed to be, a tool for the worst conditions that humans have managed to create for one another, built by people who understood those conditions from the accounts of men who had survived them. It is 7 inches of deliberate steel, shaped by necessity and proven by 80 years of field service. It does not ask to be admired. It does not require belief. It requires only that you carry it, maintain it, and trust it when trust is the only currency left. The Marines who carried it at Guadalcanal are mostly gone now. The ones who carried it in Korea are in their 90s. The ones who carried it in Vietnam are grandparents. The ones who carried it in Iraq and Afghanistan are in their 30s and 40s, living lives shaped by experiences that this knife was part of. The knife itself, this particular design, this particular steel, this particular geometry, continues to be made, carried, and used. In the world of military equipment, where doctrine changes, technology leaps forward, and yesterday's cutting edge becomes tomorrow's obsolete platform, the survival of an unchanged design for 8 decades is not inertia, it is validation. The design solved the problem. The problem has not fundamentally changed. The design remains. The man who reaches for this blade in a critical moment is not reaching for history. He is reaching for what works. He is reaching for what has always worked. The blade does not remember the war. The war remembers the blade.